So now let's start practicals of OSPF. So first of all, I'm going to implement single area OSPF, and with using very small diagram, right? I will teach you that what are the advantages of implementing single area OSPF, and also what are the disadvantages of implementing single area OSPF first. And then after, I'll be teaching you about all network types, as well as something related to timers, authentication, all basic practicals. So today we are going to perform all basic practicals of OSPF. We will talk about the basics of OSPF, and then from tomorrow and onwards I'll be going for some higher level practicals of OSPF, right? So let's go for this basics of OSPF first of all. So I'll connect some routers in a serial, like R1, R2, R3 is there, then R4 is there, and let's say R5 is also there, right? So I have taken 5 routers here. I will interconnect all these 5 routers together with using serial links as well as Ethernet links. In between some routers I'll be using serial links, and in between some routers I'll be using Ethernet link. So let me add this serial slot first of all, and then I have connected R1 with R2 with using serial interface. Then I will connect this R2 with R3 as well. Then I'll connect this R3 with R4 as well. You understand? And then finally I'll connect this R4 with R5, but this time I'll be using Ethernet link, so that we can also perform the election of DR and BDR. If you want, then I can also take more than 2 routers in a single multi-access network. However, we can also perform DR BDR election with using 2 routers as well. It's not mandatory, it's not compulsory for us to have more than 2 routers in a single multi-access network. So is there any problem now? So this is going to be your diagram, and accordingly I'll do configuration, and we will perform all practicals of OSPF, basic practicals. Let me start all routers, and then I'll be allocating an IP address in very simple way. Yes, in between R1 and R2 I'll be using 12 network. In between R2 and R3 I'll be using 23 sub network. In between R3 and R4 34 sub network, and in between 4 and 5 I'll be using 45 sub network. Then I'll be using loopback interfaces as well. Like here, let me show you 12.1.1 on R2, 12.1.2 on R3, 23.1.2 on R3 it will be 23.1.3 on R3 is S1 by 134.1.3, and here I'll be taking .4. Here I'll be taking an IP address like 45.1.4, and here I'll be taking .5. Understood? Good. Let me create some loopbacks as well. Like on R1 I'll be using 1.1.1. On R2 I'll be using 2.2.2. On R3 I'll be using 3.3.3. On R4 I'll be using 4.4.4. and on R5 I'll be using 5.5.5. Yes. Finally on R5, and here IP address will be 45.1.5. Fine. See, show IP route. Only directly connected networks are there. Show IP protocols. No routing protocol configured. And let's say router. Fine. Process ID, you can take any process ID number. Anything in between 1264535. As I said earlier on that here I'm gonna to implement single area OSPF only. So let's say I have taken one. Now you know very well the procedure that how can we allocate router IDs to OSPF. First one, statically you can configure router ID. Second, highest loopback. Third, highest physical interface IP. Active interface is IP address, right? So here I'm going to allocate its router ID manually, and router ID is going to be 1.1.1. Now to enable OSPF on interfaces, you have two options. You have two different options available. One by using network command, and also you can enable OSPF by configuring command under interface mode as well. You understand? I mean, you can also enable OSPF explicitly under interface mode as well. So here you are having two different methods by which you can enable OSPF on to interfaces of your devices. So this time I'm gonna to use like as you know network 12.1.1, and then I can take its wildcard mask because I just wanted to enable OSPF only on that interface who is having an IP address like 12.1.1.1.1 only, right? That's why I have taken its wildcard mask as 0.0.0 because in wildcard mask the meaning by zeros is what? Must match. Then I will define my area ID. Area ID is what? 0. So this time show IP OSPF interface brief. You can see that OSPF has been enabled on this interface. Then if you want to enable it on loopback, then you can also use this method to enable OSPF on your interfaces of your device. Like you can move under interface mode, and then you can say IP OSPF. You understand? IP OSPF is what? 1, and then area is what? 0. So I wanted to enable area 0 onto this interface. So in this, with using this method, actually you can enable OSPF under interfaces or onto interfaces of your device, right? So here you are having two different methods, unlike ESGRP, because in ESGRP we were having only one method to enable, and which was with using network command only. But here in OSPF you have two different methods to enable OSPF onto your interfaces of your device. One is by using network command, another one is as you know, right? So in this way you can enable OSPF. So let me show you IP OSPF interface brief. This command will be used by you to ensure whether OSPF is enabled onto interfaces or not, right? So on these two interfaces now OSPF has been enabled. Then you do one thing, move on R2, say router OSPF 1, router ID 2.2.2, and then because here I'm going to implement single area OSPF, so I can also say network 000 255 area 0. So you will, I mean the meaning of this command is what? That on all interfaces of this device OSPF will get enabled, right? So you can see that OSPF area 0 will be enabled on all interfaces of this router. Is not it? In same manner, I will move on R3. I'll say router OSPF 1, router ID is 3.3.3, network 000 255 area is also going to be 0. In same manner, I will move on R4. Router OSPF 1, router ID is going to be 4.4.4, network 0 0 0 0 245 245 and again area 0 here, area 0, because I want you to enable area 0 only here on all interfaces of this router 2. Now let's move on R5. On R5 as well, I will say router ospf1, router ID is going to be 5.5.5 network 0 0 0 and it's wildcard mask now, and then area ID is what? 0. Show IP ospf interface brief, you see. So now I have enabled ospf on all devices here. After enabling ospf, now let me show you routing table of R1. So it must learn all other routers loopback interfaces, as you can see here, 1 2 3 4. Even 555 will also be available, but might be it will take some time here, because the neighborship will take some time to come up into full state in between R4 and R5, because first of all they have to perform DR and BDR election. Because here I am using Ethernet connection, as I said that if you are using Ethernet connection, then of course by default DR BDR election will be mandatory for that network segment, right? So now you must have here 5.5.5, so you have learned it now. So is there any problem now? Fine. Now once again let me show you something here on R1. No router ospf1. I have removed this ospf once again from here. Show IP ospf, show IP protocol. Actually, is there any protocol now? Show IP ospf database. Is there any database? I mean, is there anything available inside the database of ospf? Because you have completely removed the process of ospf from this device. Now you do one thing, move on R2 on its S1 by 0. I'm gonna to shut it down, so that R1 will not be able to form neighborship with R2 immediately. Are you getting a point? Okay. That's why I have shut it down right here. Now let's move again back on R1. I just wanted to show you that whenever you will enable ospf on any device, it will immediately generate its own router LSA. As I said earlier on, that wherever you will enable ospf, it has to generate router LSA, and it has to store that router LSA inside its own database table. So this time on R1, I'm gonna to do that once again. Router ospf1, router ID is 1.1.1, and then say network 0 0 0, and then it's wildcard mask 245 245 245 245, and area is going to be 0. So show IP ospf interface brief. You can see that on all these two interfaces ospf has been enabled. Show IP ospf neighbor. There is no neighbor. Show IP ospf database. Inside the database, it is having its own router LSA. If router link state is stated here, it means this is kind of router. I mean, this is router LSA. See, the meaning by router link state is router LSA. Is there any problem now? Right now, you can see that it is having only one router LSA inside its own LSDB link state database, because it does not have neighborship with any other router here. That is why it is not having other routers, router LSAs available inside its own database table. So it can also have others router LSAs inside its own database table, but after forming neighborship only. So you will never get the router LSAs in the database table of any router till it is not having neighborship with other routers, right? Yeah, you can find its own router LSA inside its own database table even without forming neighborship with other routers. So this time you can see that you can find its own router LSA inside its own database table. And as I said that in router LSAs, advertising router ID as well as link ID will always remain same. So how many links are there inside this router LSA right now? Only one is there. Sequence number is what? Because I said that to each LSA there will be a sequencing, right? A sequence number will always be allocated to your LSA. So whenever there will be any modification in your router LSA, whenever there will be any change inside your router LSA, it will regenerate whenever there will be any change on this router. Are you getting my point? Whenever there will be any change on this router, then it will immediately regenerate its own router LSA with the higher sequence number. Or you can say that its sequence number will always be incremented by 1 whenever any change will occur on this device now, right? So this time its sequence number is 1. You know why? Because I just enabled ospf on this device, right? So this time it is having only one links information inside its own database table, inside this router LSA. As you can open it as well, show IP. And one more thing, this router LSA is only for area 0, not for any other area. Now let me show you. Show IP OSPF database router and 11111. You can see that router LSA which is generated by 1.1.1.1. So it is having only one links information, which is what? loopback. So it does not have, I mean, it is not having the information about serial interface. You know why? Because the line protocol is down at the end of R1. Show IP interface brief. As you can see, that line protocol of the serial interface is what? Down, because we administratively shut down this link on another end, right? So its line protocol will remain down until on another end you says no shutdown, or until the another end is down, right? So now move on R2, say no shutdown, right? Say no shutdown. You will see that this line protocol of this interface will come up and also will form OSPF neighborship, right? So I will show you each and everything which is performed by OSPF during formation of neighborship. You see, line protocol have came up at same time, neighborship have also came up now. Show IP OSPF database. This time its router LSA will be incremented by, see, a sequence number. Still it is having its own router LSA, but this time you can see how many links are there? 3. How many links are there? Under link you can count them. Under link count you can see that how many links information are there. So how many links are there on R1? No, only 2 links are there on R1, but it is showing you 3. You know, you must remember one more thing here, that if your network type is point to point on any interface, by default on all serial interfaces your network type in OSPF is what? Point to point. So you must remember this rule of network type point to point, that if your network type is point to point, in that case it will create another entry for point to point connection, right, in its database table. So total number of, I mean, one serial link will be treated by default, one serial link will be treated as 2 links. By default serial link will be treated as 2 links. Let me show you. Actually show IP OSPF database, it is showing you 3 links. However, show IP OSPF interface brief, only 2 links are there, but it is showing you 3 links. Now let me open router LSA generated by R1. Show IP OSPF database router generated by 1.1.1. So this time you can see, let me enlarge its window. How many links are there? 3. And now you can see one point to point connection, one point to point link have been created here in its database table by which another router is connected. And it is also showing you that what is the cost to reach this neighbor. It's not it. It is also showing you that what is the cost to reach this neighbor. So it found this neighbor here on this network, and the neighbor's router ID is this. And what is the metric to reach this neighbor here? 64. How will it come to know that okay, it is having neighbor on this interface or on this subnet? By looking at database table, how can you specify that okay, it is having neighborship? We are saying that OSPF is a fully linked state routing protocol. Then how can you say that okay, it is a fully linked state routing protocol without having a complete information, without having a topological database? Are you getting my point or not?
Yes.
Hello?
Yes.
Try to understand that if this entry is not there, how will you come to know that okay, R2 is connected with R1? By looking at its database. That is why inside its own database table, this information is also mandatory to have that which routers, which router is connected with which router. So in case of point to point, if your network type is point to point, then it will also create one point to point entry, because if your network type is point to point, means that in that segment you are having only 2 routers connected. If your network type is point to point, it means only 2 routers are interconnected in that segment. So which router is the second router? That information will be given by this entry. And because here now it is having 3 links information here, that is why total number of links inside this router LSA is what? 3. However, physically it is having only 2 links. Now as I said, see, I am not gonna to look at the physical diagram, but I will draw this diagram by looking at its database table only. I'm not gonna to look at the physical diagram. I will look at database table only, and I can draw this diagram very easily. Show IP OSPF database. As we can see here, that how many router LSAs are there? 5. 5 router LSAs are there. What does it mean that 5 routers are participating in this topology, in this area 0? 5 router LSAs specifies that 5 routers are participating in area 0 in this topology actually. One network LSA is also there, and we know very well that network LSA is for area 0 only. It means in this area 0 we are also having some DR and BDR as well, and this is generated by 555. It means it is generated by R5, right? So we will see that who is R5, we will see that, but later on. Let me draw this diagram by looking at its database table only. Now me I know very well that I am R1, and R1's router ID is what? 1.1.1. Are you getting my point or not?
Yes.
Show IP OSPF database router LSA. I'm gonna do open router LSA, that is why I have a specified router here, and then 1.1.1 generated by 1.1.1. See, 3 links information is there. One is your loopback interface 1111. One is your stub network, which is configured on your serial interface itself 12.1.0/24. Matrix is what of this interface?
64.
Because on serial link, on serial interface by default bandwidth is 1.544 Mbps. By default formula is 100 divided by bandwidth in Mbps, so it will definitely come as 64. Then how will you come to know that to whom it is connected? So it can show you here under point to point that it is connected with another router, point to point another router, and neighboring router ID is what? 2.2.2. And what is the cost to reach this neighbor? 64. So now we are connected with 2.2.2. Now you can open router LSA generated by 2.2.2.2.2. So say show IP OSPF database router and then generated by. So 222 is having 5 links information. However, we know very well that R2 is having only 3 physical interfaces, 1 loopback and 2 serial interfaces. As you can see here, one is loopback, subnet mask is /32, because you must remember that in OSPF loopback interfaces will always be advertised on /32. Now you can see that it is also connected with another router, and its router ID is what? 3.3.3. and what is the cost to reach this 333 is 64. And it is also having one stub network which is 23.1.0, right? And it is also having one another router connected with it, which is R1, which it is also connected with our router as well.
Yeah.
It's not it, because all routers will be responsible to generate router LSA. So this R2 is showing us that it is connected with R1 as well as with R3. It is not connected with any other third router. It is connected with R1 as well as R3 only. So now from R1 to reach R3, what is the cost? 64. So we are having this information that R1 is connected with R2, R2 is further connected with R3. Then you do one thing, open router LSA generated by R3. Show IP OSPF database. Show IP OSPF database router 3.3.3. Now it is also having 5 links information. It is connected with 4.4.4 as well. What is the cost to reach this 4.4.4? Is 64. And then also it is connected with 2.2.2.2 as well. Of course we have already seen it, right?
Yeah.
Like R2 is connected with R3, right? So R3 is further connected with R4 as well. Is not it? And all others are what? Stub network. Is not it? I will show you, I will teach you that what is the meaning by stub network as well. But for now, let's go for the router LSA of R4 itself. Show IP OSPF database router generated by 4.4.4. You can see now how many links information are there? 4. Stub network is 4.4.4. Point to point. Yes, it is connected with R3. We know very well that R3 is connected with R4, right? then it is also having one other stub network which is 34th network, and also it is having one transit network. Now this is really important to understand this transit network. Remember that if you're inside the database table, inside router LSA, any network is specified as transit network, any network is specified as transit network, remember it means your network type is broadcast over there and you are having DR BDR election. You are having DR and BDR election. So we know very well that now designated router is what, 45.1.5, and router interface address is what, 45.1.4. this is our address, this is our address, and this is what, DR's address. Now if you want to see that in this transit network how many routers are there, in this transit network how many routers are there, because we don't know, because it will be having information about the DR. I mean this transit network will be having an IP address of DR and its own IP address. So it is having its own IP address which is 45.1.4, and also it is having the address of DR which is 45.1.1.5. Now we don't know about the DR others, might be that it is having multiple DR others over there, we don't know, we can't say anything right now. We are assuming that we do not have the physical diagram of OSPF right now. I mean we do not have the physical diagram of this topology right now. So if you want to see that how many routers are connected in this multi-access network, in this transit network, for that you have to open route network LSA show IP OSPF database network and generated by 45.1.5, because this is DR, this is the DR address. You, hey guys, try to understand, this is the DR, and DR would be responsible to generate network LSA. So say network and 45.1.5, because it will be generated by R5. You see how many routers are there? Test router 4 and 5, only 2 routers are there. Are you getting my point or not?
Yes.
And what is the subnet mask running in between these two routers? /24, and this is the address of DR, and it is generated by R5. It is generated by R5, means we are also having one another router R5, so we can also open router LSA of R5. So now you see show IP OSPF database router 5.5.5. so is it connected with any other router now? No. So it has proved R1 is connected with R2, R2 is connected with R3, R3 is connected with R4, R4 is connected with R5, and in between R4 and R5 we are having the election of DR and BDR. Have you understood it or not?
Yes.
So wherever you will be having transit network, it means it will be mandatory for your devices to elect DR and BDR. And if you are having point to point, means there will be one another entry for point to point, but there will not be an election of DR and BDR.
तो जो ये अपने जो पॉइंट टू पॉइंट होता है उसके अंदर ही शो करता है कनेक्शन, साथ में R1
यहाँ पे LSA अलग हो गया ना, वो सोचो.
ट्रांजिट नेटवर्क मेट्रिक है
What? This is this transit network, of course, because it is connected, it is reachable. I mean this transit network is connected with FA0/0. So this is the metric of that interface. Let me show you show IP. Huh? See. So by looking at only one router, you can draw entire diagram.
टोटल कॉस्ट है उसमें बता देगा, ये पर्टिकुलर उस इंटरफेस की कॉस्ट बताएगा.
Now, remember, once database is built, once database has been created, I mean LSDB, then router will always think that I am a central point, I am a root, I am a root, kind of root bridge. I am a root. Guys, try to understand.
Yeah.
Because in OSPF all routers will be responsible to elect their best path independently. No one will inform to their neighbor that okay, this is your best path. Never. They will exchange their database only. So this time in OSPF there is a rule that after maintaining LSDB, link state database, they will run SPF algorithm onto it now. SPF is what? Shortest path first algorithm. and then it will create SPT, shortest path tree, and it will mention, it will assume itself as a root now, and then accordingly it will create that SPT, shortest path tree. Are you getting my point or not?
Yeah.
See, router will assume that it is a root, and by assuming itself as a root, then it will create SPT, shortest path tree, and best routes will get installed inside its own routing table. And you see, if you configure this command on our one show IP protocol, gateway of information sources, in distance vector routing protocol, you will always find your neighbors only under this option, routing information sources. Under routing information sources, in all distance vector routing protocol, you will always find only and only neighbors. But in OSPF, because you do not depend on that information which is given by neighbors, here it is getting this information individually from each router. It is getting this router LSA from each router, and then independently it is responsible to elect its best path. Are you getting my point or not? So here it is not showing you only neighbor, whereas in distance vector routing protocol it will always show you that okay, this the source of information is what? Neighbor only. But this time, of course, it is not gonna to show you that okay, routing information sources or routing information source is just your neighbor. Never, because neighbor is not your, this time in linked state routing protocol, it is not depending on that information which is given by its neighbor. Even you can see that no one modified anything existing any LSA. No one modified anything in existing LSAs. Have anyone modified any LSA? Like if LSA is generated by R1 have given that its own router LSA to its neighbor R2 have not made any change in it. And without changing this LSA, without modifying, it will advertise that LSA towards its another neighbor. So remember that in OSPF, routers will exchange their LSAs without modifying them. They cannot perform any type of modification. That is why R1 is saying that okay, the LSA of R5 is given by R5 itself. It is not showing you that okay, it is given by R1. Oh sorry, it is given by R2. Because R2 is not providing it to R1. R2 is just doing what? Like R2 got it from R3, but actually R3 got it from R4 and R4 got it from R5. And without doing any modification in that LSA, they are giving it to their neighbors. That is why here we are saying that it is a fully linked state routing protocol. If it is not happening, if it is not happening like that, if it does not perform like that, who will say it that okay, this is a linked state routing protocol or this is a fully linked state routing protocol? Are you getting my point or not?
Yes.
Have you understood it completely? Fine. Let me do one thing now. I'm going back again on R1 and I'll say no router OSPF1 so that it will remove the whole database. R2 will also break its neighborship.
Yes.
Shut it down. Understood? Fine. Now I'm gonna to capture this link. Let me show you debug. Now shut down. And then after I will enable OSPF on R1. Area?
0.
Now you see. Neighborship have came up now. Done? Fine. Let me stop it now. See. This hello is generated by R1 first. In this hello, as I said that first, in all type of packet, whether it is hello, LSR, sorry, DBD, LSR, LSU or LSAC, in all types of packets, first 24 bytes will remain same. That is also known as ospf header. So I have opened this hello packet now. Inside this hello packet, this is your ospf header, and this is always gonna to be same in all. And I told you that this hello packet will be having version, type, length, source router, area ID, packet checksum, type and authentication data. But by default your authentication type is what? Null. That is why it is showing you here null. Any problem? Are you okay with it? Fine. This is the information contained by ospf header. Then you can open this hello packet. This information is contained by hello packet. Network mask, as I said, subnet mask must match. That is why hello packet is responsible to contain your network mask information as well. Hello interval, your option bits, if it is an SSA, not an SSA or whatever it is, you understand? So all these things are there. Priority is by default
1.
Dead interval is what?
40.
Is there any DR?
No.
Is there any BDR? Are you getting my point or not? Fine. Then after you can see the hello packet generated by R2. This is also multicasted with using .5. Active neighbor. This is generated by R2.
पैकेट लेंथ 48 है. ये सिर्फ हेडर की बता रहे हैं, पूरे पैकेट.
पूरे पैकेट की, मतलब ओएसपीएफ की जो इन्फॉर्मेशन है उसकी बता रहा है. टोटल लेंथ तो आईपी हेडर के अंदर होगी ना, वो इसके ऊपर है आईपी हेडर के अंदर. यहाँ पे हो गया ना 80. See, the hello packet generated by R2 is containing its neighbor router ID. So once R1 will receive it, will move into two-way, because R1 will get its own router ID inside received hello packets. Fine. So here you can see that active neighbor is 1.1.1. And then after, once it moved into two-way state, it have immediately generated, see, R1 received hello packet from there, and again it have generated one hello packet as well as DB packet. See, the first DB packet will be blank. It will be blank because it will be used for those DB packets to elect your master slave. It means that in XStart state also they will exchange DB packets. Generally we says that DBD messages will be exchanged during exchange state only. No. During XStart state 2 they will exchange their DB packets, but those DB packets will be empty DB packets, just to perform election of master and slave and to negotiate sequence number of DBD packets. Leo, try to understand it, right? So this time this R1 have generated a DB packet as well as, because just now for R1 neighborship moved into two-way state, right? And after 2-way it has put it into XStart state now. So at same moment it has generated this hello as well as this DB packet. So this hello packet is containing the active neighbor's IP address, which will be this time 22222. So that R2 will also move into two-way state. Are you getting my point or not?
Yes.
That is why R2 have also generated now DB packet. Fine. Let's open that DB packet which is generated by R1. This is. Open it, and this is your DB packet. Type is what? 2. Hello.
Yes.
This is ospf header. It will be common for all. Is not it? Then after it, let's open this DBD. See, this R1 said that okay, let's start our sequence numbers of DBD packets from 4905. Hello. It can, I mean, routers can pick any random value. So this time they have said that okay, DD sequence, let's start this DD sequence number from 4905. I will also let you know that why this sequence number is mandatory, is compulsory for DBD packets. Are you getting my point or not?
Yes.
Great. Now inside DB description, M means, I means this is the very first DB packet generated by this router. This I bit specifies that this is very first DB packet generated by this router. This M bit, more bit, says that it is also having some more DB packets. This is not the last DB packet. Then MS bit, it is saying that I am master. If MS bit is 1, it means it is saying that I am master, because both of them will specify that they are master. Are you getting my point or not?
Yes.
So this DB packet is generated by, tell me, R1, and MTU's information is also contained by this DB packet. Fine. Then next DB packet is generated by R2. This DB packet is generated by R2. It will also say the same thing, that okay, this is the init, very first DB packet generated by this router. It is also saying that okay, some more DB packets are to be follow,
And it's smart.
and it is also saying that I'm master. But any one of them will be elected as master, either R1 or. Then first of all they will compare their priorities. Priorities they have already exchanged in hello packets. Then they will compare their router IDs. They already have their router IDs. They already have each other's router ID, so they can elect master and slave very easily. And it has said that okay, sequence number is what? 6176. So which one will be winner? Of course R2. So this is generated by R1 now. Next DB packet has been generated by R1. And see, in this DB packet it will say that I am not a master, and also I will be using your sequence number. I'm negotiating that I accept your sequence number.
Okay.
Hello.
Yes, sir.
R2 क्यों बनेगा तो master?
Wow.
Router ID.
Great. Priority is by default,
Same.
and higher router ID.
ये sequence number जो होता है उसके base पे नहीं बनता है।
Nope.
मैंने देखा है इसका मतलब ज़्यादा होता है, पता नहीं कम होता है, हमेशा ज़्यादातर वही होता है।
No. I said whoever will be having higher sequence number, I mean the DRC, actually master sequence number would be negotiated. It doesn't matter whether it is higher or lower. This is generated by now R2. Next packet. See, okay, first of all let's see.
Not the slave thing.
Wait. MS bit is now clear.
0.
Means it is not a master. And it have also negotiated sequence number. See, 6176 given by R2. It does not have any other. See, more bit is not set now. What does it mean? That it does not have any other DB packets now. Are you getting my point or not?
Yes.
Fine. It have specified that it does not have any other DB packet now. And you know why have it shown you, or why is it saying that okay, I don't have any DB packet? Because it was not having any LSA available inside its own database table except its own LSA.
Yeah.
And remember that if router is having only and only its own router LSA, then it will never inform to its neighbor that okay, I'm having this LSA, because this is predefined that of course neighbor is having its own router, let's say. Are you not getting my point? Let's say me and Ujjwal, we both are going to form OSPF neighborship now. So I will never inform to Ujjwal that okay, I'm having this router, let's say, because this is predefined that Ujjwal must know it, that at least I will be having my own router, let's say, in my database table. Because he is going to form neighborship with me, so at least he must be having my LSA.
Yeah.
So because R1 was not having any LSA inside its own LSDB, are you getting my point or not? Because I just enabled OSPF on R1, it was having its own router LSA only.
Yes. So जब आपने पहले दिखाया था तो उसमें भी 1 बिट थी ना.
हाँ.
उसके अंदर भी तो वो जो R1 है.
हाँ.
तो ये बोलेगा ना कि भाई.
अरे तो तब तक मास्टर स्लेव इलेक्शन तो नहीं हुआ था ना, नेगोशिएट भी नहीं हुआ था सीक्वेंस नंबर. Fine. And now it is giving this DBD to R2, and then R2 will be responsible to generate it now. See, R2 have generated this DB packet now. See, this is, and in this DB packet, let me show you OSPF DB description, sequence number 61, which is the next sequence number this time, because whenever master will generate next DD. See, let me explain you the uses of sequence number for DBD in OSPF. Try to understand. We are having LSEC, external acknowledgement, but only for updates, LSU. Do we have any LSEC for DBD packets? Try to understand my point. Do we have any kind of acknowledgement for DBD packets in OSPF? No. Are we using TCP for OSPF? No. So in case if DBD lost somewhere in the network, how will you come to know that okay, it was not delivered? So for that purpose, here in OSPF we are having sequence number for DBD packets. What happens? Let's say this is R1, this is R2. Now this is master, let's say, and this is what? Slave. So let's say they have negotiated with sequence number 10. So whenever because master will be responsible to send DBD first now, is not it? So this master will send DBD packets with sequence number, let's say 10. So now it is mandatory that whenever a slave will receive any DB packets with any sequence number coming from master, it has to give response back. Rejuvi. Sorry? Okay, meditation. You have very strong meditation. Good. And you are doing meditation inside the classroom. Great. So R2 will send a DBD back to R1 in the response of received DB packets coming from R1, but with the same sequence number. And it doesn't matter whether R2 is having any information to provide to R1 or not, doesn't matter. But if slave have received any DB packet coming from master, slave has to respond back. Doesn't matter whether it is having any information to give to master or not, but it has to respond with DB packet with same sequence number. If slave do not have any information to provide to master, then slave will send a blank DBD but with the same sequence number which was received from master. So this time R2 is gonna to send this DBD back to R1 with same sequence number. So once this master will receive this DBD coming from slave with the same sequence number, it means it will get confirmed that the DBD generated by R1 has been delivered successfully on master, on slave. Then if master is having some more information to provide to slave, then master will send another DBD but with higher sequence number this time. Then R2 has to respond back once again. Does not matter whether R2 is having information to provide to master or not, but it has to give response with DBD with same sequence number. So DBD once again and with same sequence number 11. Now there can be a different thing as well. There can be a different thing as well. How? For an example, let's say this is R1 and this is R2. This is master and this is what? Slave. But this slave is having a huge database. Are you getting my point or not? This slave is having a huge database. So let's say master was having only one LSA. So now master will send first DBD in which it have given that information to slave with sequence number, let's say 10. Now slave have to give DBD back to master with sequence number, with same sequence number. And let's say that it was not possible for slave to explain, to describe its entire LSDB within a single DBD packet. Fine. So now how will it be possible for slave to send other DB packets in the direction of R1? Because slave can send DBD packet in the response of that DBD packet which is coming from master only. It cannot generate it from its own end. Are you getting my point or not? See, slave do not have that authority, that capability to generate DB packets by its own. It can generate DB packets in the response of that DB packet which is generated by master only.
They set the mode bit and center.
Exactly. See what will happen now, that if slave is having some more information to provide to master, then it will set more bit here with same sequence number. Now when this master will receive it, it will receive this DB packet with sequence number 10. It means the DB packet generated by master have delivered onto slave, but it have received this DBD coming from slave with more bit. It means that slave is also having some more information now. So this time, because master do not have anything else to provide to slave, but it is mandatory, it is compulsory for master now to send another DBD with higher sequence number, and it could be anything. I mean, it can be blank DBD as well. So with higher sequence number. So now R2, this slave, you understand, will send another DBD with the same sequence number, and if it is still having some more information to provide, then again M bit will be 1, more bit will be 1. Are you getting my point or not?
Yes.
In same manner, master can also have some more information as compared to slave. So whoever will be having some more information, then they will always use M bit, more bit, to inform their neighbor that I'm still having some more information to provide you. The same thing is happening here. Like this time this DBD is generated by, see, when last DBD was generated by R1, right? And in that DBD it is specified that it does not have any more DBD, because we saw that it was having M bit as 0. Are you getting my point or not?
Yes,
See,
sir.
this is generated by R2, but it was generated by R1. So in it was having M bit as 0. Now it is generated by R2. R2 is having this, and in it, see, as I said, that DB will be responsible to take your LSA headers. So what is that? So R2 was having 5 router LSAs in its database table, because R2 will see OSPF keeps your LSA for 60 minutes in its LSDB. So R2, and here there is no rule of split horizon as well. So R2 was having LSA generated by R1 as well in its database table. So when they formed neighborship, then R2 informed to R1 as well that I'm also having the LSA generated by 1.1.1.1, but R1 is not going to accept it. R1 will not accept it because it will be old, its checksum will be different, might be sequence number can be higher, and might be R1 sequence number is what? Lower, but due to time and checksum, R1 will identify that okay, this LSA is what? Older LSA, old LSA. So I should not accept this LSA, because R2 is, see, guys, try to understand. Previously R1 and R2, both of them were having neighborship, is not it? Fine. R2 was having the router LSA generated by R1 in its database table. Then what I did, I removed OSP from R1 So R1 removed its own database, but did I remove anything from R2? R2 was still having the LSA generated by R1, right? Because routers will always keep your LSAs inside their database table for 60 minutes. Refresh interval is 30 minutes, so they will send periodic updates after every 30 minutes, but they can keep your LSA inside their database table up to 60 minutes. Are you getting my point or not?
Yes.
That's okay. That is why when R2 given its DB packet to R1, it included all LSAs in that DBD which were available inside the database table of R2. See, 2, 3, 4, 5. Oh, okay. Actually, R1, it means, okay, it didn't provide the header of that LSA which was down actually, because it was down, right? But it still, R2 was having 5 LSAs because network LSA was also there. Hello?
Yes, sir.
Network LSA was also there. However, it should have given only 4 LSAs information, 4 LSAs header, but it was having 5 LSAs. Network LSA was also there. That is why total number of LSA headers are 5. And inside this DB description, see, mbit is what? On. It means
More.
yes, more bit. It means it is having some more DB packets. Fine. Now R1 received it and R1 regenerate its DB packet with the same sequence number which came from, see, and it does not have anything in it. Does it have? So this is blank DBD. It does not have any LSS information in it. Then R2 have again generated this DB packet, but this time mbit will be 0. This time mbit will be 0 because now R2 is not having anything to tell to R1 because R2 have already given its whole information to R1 now. Hello?
Yes, sir.
With higher 6178. Now slave will come to know that there is no other DB packet, right? Slave. That is why it have generated, tell me, LSR, link state request. So R1 was not having any LSA inside its own database table, right? Was it having? No. So inside this request it will specify all that, all that advertisement ID and link ID for which it wants LSA, for which it wants information. Hello? So R1 received LSA headers given by R2 for all those 5 LSAs, and R1 was not having any one of them because I removed the complete database of R1. So in this LSR you will be having all that complete information. See, 5 LSR inside a single packet because it was not having any LSS information inside its own database table. And that is why it is good feature in OSPF that they keep LSS inside their database table for next 60 minutes. In case if neighborship goes down, then next time whenever neighborship will come up, they will not require to send too much updates to each other. So it will compare its database after receiving DB packets. If it finds that okay, I'm already having complete database, only some information is missing, then it will send a request to its neighbor to send that small information only, not for entire information, not for entire updates. But very first time it has to give all updates. That is why this R1 have generated LSR for all LSSC, and in this LSR it is having type, link ID and advertising ID in all. See, this is network LSA. It's not it. So this is all about LSR. Now this LSR will be received by
R1.
okay, R1 have also generated this DB packet as well because it received that DB packet came from, because if slave receives any DB packet from master, it has to give the response, right?
Same thing.
See, with the same sequence number, but it does not have anything in. Is not it? Then after it, see R2 received LSR.
So we are in loading state. Huh?
Yes, now you are in loading state. Because during exchange state they have exchanged their DB packets. Inside DB packets you are having the LSA headers.
Yeah.
And when it have sent LSR and now they are giving LSU, see, so it is loading state.
Loading state.
It is also multicasted. See, all packets are multicasted.
Yes.
Even LS act.
तो रिक्वेस्ट पर्टिकुलर एक कर रहे हैं ना,
So what?
तो मल्टी कैसे करेगा?
By default. See, in update also, the header, OSPF header is common, same as other packets, but it is having now, see, LSAs, complete LSA, not LSA header.
Even we can find VE.
Exactly, everything. See, let me show you. LS type. This is router LSA. Who taught you CCNP?
Ajay Paul.
LS type router LSA. You understand? LS edge is what? Do not edge is not there. And this router LSA is generated by 2222. You see, and it is having how many links information?
4 links.
Four links information. And these links are, see, is not it. Then it is also having one another LSA which is generated by, see, R3. Right now it is not the endpoint of virtual link, it is not the SBR, and also it is not a border router. These are 3. Generated by R5 also. So this is the only thing that you were having in the database table of R1. So that is given by, see, in the form of LS U. And then in the response of LS update, you see R1 also have given, see, R2 have not generated any LSR to R1 because R1 didn't tell to R2 that okay, I'm having this LSA inside DB packets. But again R1 have to send update it at its own router LSA to its neighbor, right? So you see R1 have given it, see, its own router LSA. It's not it, in which it is specified that I am also connected with point-to-point neighbor 22222, and what is the cost to reach it? 64. Now it came to know, R2 came to know that okay, on this segment I am also having one other point-to-point neighbor, right? So now it have generated one another update, but in this update it will not be having a complete, I mean all router LSAs. In this update it will not specify all router LSAs because this point-to-point has been added in the router LSA of R2 only. So the sequence number of router LSA of R2 have been incremented by 1 after knowing that okay, there is a router, point-to-point router, and the neighbor's router ID is this. So it will add that entry inside its own router LSA, so that when what I said, that whenever there will be any change inside your router LSA, its sequence number will be incremented by 1 and it will immediately inform to its neighbor in the form of LSU. So this time this R2 have generated another router LSA, another update, but in this update it will not be having all router LSAs. It is having only one router LSA, see, generated by R2 only, and this time it have also added this entry point-to-point with R1. And finally add acknowledgement generated by R1 as well as R2. Inside LS acknowledgement it is sending headers of all received LSAs. Hello.
Yeah.
In LS acknowledgement, see, this is what acknowledgement type 5. It is having headers of all LSAs that it is having, not received, that it is having inside its own database table. So it is having now 6 LSAs.
One network.
One network LSA and 5 routers are participating. So 6 headers are there. Are you getting my point or not? So inside header, see only sequence number, advertising ID, linkage state ID, LS edge, checksum, all these things. Sequence number is not it. So it has given this acknowledgement to R2, and R2 have also given this acknowledgement to R1. And see, because R2 received only this information from R1. Understood? So this is OSPF neighborship states, and this is the role of their packet.
सर जो 1800 सेकंड और 3600 सेकंड होता है ये हमेशा एग्जैक्ट क्यों नहीं होता?
36 what?
जो 1800 सेकंड होता है आधे घंटे बाद रिफ्रेश करता है और जो 3600 होता है
एग्जैक्ट क्यों नहीं होता? होता है, किसी ने कहा एग्जैक्ट. Fine. So this is all about packets, and here I said debug. So two-way, receive DB DX start, then exchange, then LSR, received LSU, synchronized database, and now neighborship have moved into, because just after synchronizing database, your neighborship will move into full state now. Is not it? Good. Show IP OSPF database. The sequence number of router LSA generated by R1 is what? 2. Right? Great. If you move on, R2.
तो यहाँ पे देखो एज 920 एज
मतलब रिफ्रेश नहीं किया रहा इसने.
No, actually we broke the neighborship only between R1 and R2.
I will see it and then we'll let you know that what is the reason behind it. But ideally it's LSA refresh interval is by default 30 seconds and flush interval is 60 seconds, right? Sorry, 60 minutes, 30 minutes and 60 minutes. Fine. So this time the sequence number of a router LSA generated by R1, check it out, is 2. Hello? On all devices, its sequence number will be 2. On R2, on R3, even timer edge is also same. On R5 also.
क्या हो गया सर 2000 को
Fine. Then after it, let's move back on R1. Let's check that how many times this R1 have scheduled SPF algorithm. show IP OSPF. R1 have executed only.
One time.
Let's move on R2 now. R2 have executed
13 times.
R3
One.
R4
10 times.
hello. Now I will simply do some modification. I'll do some changes on R1 only. I will shut down its loop back. Show IP OSPF database. Its sequence number is now
3.
will it be have I mean will this router LSA be having this links information now? Even you can open this router LSA on R1 itself. Show IP OSPF database router generated by 111. Does it have 111's information now? And this update have been given to all other routers with higher sequence number now. So all of them will also accept this update. If they accept this update, it means they will also remove that route from their routing table. And now because I have shut down it over here, so its sequence number have been incremented by 1. As you can see that now show IP OSPF database, its current sequence number is what? 3. Show IP OSPF, how many times it have executed SPF algorithm now? Previously it was 1, now it is 2. Previously on R2 it executed 13 times and sequence number is now 3. And show IP OSPFC, this time it must be 14 times.
14.
Now let's move on R3. Show IP OSPF database, its sequence number must be 3. Show IP OSPF, previously it executed only 12 times, but this time it must be 13. Now move on R4. Show IP OSPF database, sequence number must be 3. Show IP OSPF, it must execute it as 11 times. Same on R5, it have also executed now 11 times, and sequence number will also be show IP OSPF database. See, it is also 3. And here if you open this router LSA show IP OSPF database router generated by 11111 here, so you will see that it does not have any information about 111111.
And sequence number of other routers also are changed.
No,
They will
never. Show IP OSPF database, the sequence number of other router LSS will never get changed.
when before it used to be 3 items.
Where when it's like for an
shutting
example
down.
it
Yeah.
was 3, but then after timer has expired, how will it be possible for others to receive this new update now after
Okay.
3 minutes, after 30 minutes? So after 30 minutes also its sequence number will be incremented by 1. That's the thing. Have you understood it now? And now if you move back again on R1 and if you say no shutdown, once again it will include this loop back inside its own router LSA. Show IP OSPF database, the sequence number will become now 4. It will give this update to all others now with sequence number
4.
whenever a router will receive any updated LSA, router LSA, not any LSA, router LSA, so it has to schedule, it has to execute SPF algorithm onto its LSDB. So this is the disadvantage of running single area OSPF. Let's say that if you are having 50 routers in a single area, so of course changes will occur frequently. If changes are occurring frequently in your network, all 50 routers will require to run SPF. All 50 routers will require to execute SPF algorithm onto their LSDB whenever there will be any change onto any router. This is the disadvantage of running only single area OSPF. So generally we do not prefer in an enterprise network, generally we do not prefer to implement single area OSPF. Generally you will configure multi-area OSPF, but if you are having let's say that you are having less number of devices, like 10 or 12 devices in the core of the network, then definitely you must configure only single area OSPF, because if you are running MPLS, then also it will be required to run single area OSPF only. Have you understood it or not? For sure. So in this way they updates to each other.
Sir, you said that if the sequence number gets finished, they will refresh.
Exactly, they will restart it from 0. Sorry, they will restart it from 1 now. They will break neighborship.
Okay. Again, they
And
will go to all the.
exactly. Understood? Great. If you want to ask any question, please let me know. For sure. Great.
सर अभी एक्स्ट्रा स्टेटमेंट MQ के
Let me show you.
तो
Interface serial 1/0, IP MTU 1490, and then say clear IP OSPF process.
लेयर 3 MQ होता है, लेयर 2 MQ होता है.
Layer 3, sir, layer 3 1500.
हाँ, और एक को सिंपल MQ हम लोग कमांड देते हैं वहाँ पर. इनमें क्या डिफरेंस है?
पता नहीं मेरे को भी. शायद मैंने बेसिक्स में बताया था ये आपको, लेयर 2 MTU, लेयर 3 MTU.
But DVD contains only interface MPU, right?
Layer 3 MTU. Layer 3 MTU with IP header only. Layer 2, the maximum packet size that can be accepted by interface, including layer 2 header itself.
पूरे फ्रेम का.
Exactly. This is the only difference in between layer 3 and layer 2 MTU.
उसके अंदर हमारा डेटा वगैरह सब कुछ input
Exactly.
होगा और इसमें सिर्फ हमारा IP है.
ये मत बोलो, ये बोलो ईथरनेट हेडर या लेयर 2 हेडर के साथ लेयर 2 MTU, उसके बिना लेयर 3 MTU. अब आ गया समझ में? लेयर 3 MTU सिर्फ IP हेडर होगा. लेयर 2 MTU किसके अकॉर्डिंगली आप डिसाइड करोगे? लेयर 2 हेडर को भी इंक्लूड कराने के बाद. So now I have changed MTU. See, on both ends. Guys, try to understand. I have changed MTU size. Here on R1 I have configured 1490, whereas on another interface you see show IP, show interface first, serial 1/0. Still it is showing you 1500 because this is what? MTU. This is not your IP MTU, whereas I changed IP MTU. To change this MTU, the command will be right. So now you can see show IP OSPF neighbor. So it means that OSPF is taking IP MTU. So OSPF neighborship is not coming up now. So it performed too many retransmission for DB packets. So that's why it have moved back into down state now. Now do one thing. Now you have two options, either configure common MTU.
Ignore MPU.
Are you getting my point? Either configure common MTU on both ends, or there is one command on interface S1/0 IP OSPF Once you will configure this command, now your neighborship must come up. Right? What? You have to configure this command only on that side which is having lower MTU size. Yes. I got my point. If you configure this command on that end which is having higher MTU size, it will not work. Even your neighborship will not come up. So you must be remember that where to apply command, not only command like okay, this is the command to configure. Like for an example, if I move back again on this interface and if I say no IPOSPF ignore, and once again I will say clear IPOSPF process. It have broken its neighborship. So IPOSPF neighbor, it does not have neighborship. It have moved into a access static state, and again I'm moving on S1 by 0. I will say IPOSPF in FTU. We'll see that neighborship will not come up now. So you must configure this command only on that end which is having lower MTU size. Remove it from here, move back again on R1. DR other. Fine. So this is all about the router LSS now. Now I'm gonna to prove you that if we implement multi-area OSPF, are you getting my point? If we implement multi-area OSPF, then we can solve this problem of executing SPF algorithm if any change occurs in one area, right? Because there is a rule in OSPF that if you are implementing multi-area OSPF, in that case, if any change occurs in any one of the area, then SPF algorithm will be executed by all routers which are participating in that area only, in which change was occurred. But in all other areas, routers will not require to execute SPF algorithm due to occurrence of change in different area. Are you getting my point or not? So let's prove it now. So this time I'm going to do one thing here. I will implement sorry, not up to here. Here. Area 0. And here I will implement area 1. Fine. So now 5. I also removed this OSPF from the database of R3. Even I will also remove it from R1 as well. So I have removed it from all routers now. Fine. Okay. All interfaces would be in area. This time, even the loopback of R3 output it in area 0 itself, but in area 1. Show IQ SPF interface. Done. Then all interfaces of R4 will be in area 1. Then let's do one thing, let's capture this link. And finally, let's move on. Area, fine. Still it is waiting for the election of DR and PDR. Now everything is done. It's done. Right? Fine. Now the update have been given to R5 from R4. From R4 to R5. Yeah, this is the update packet given by R4 to R5. See, some router LSs are there. It's not it, because in area 1 itself we are having two router LSs. One router LS is generated by R4 as well as R3. So it have given those two router LSs to R5, and also R3 generated some summary LSs for area 1. So all those LSs information is going from R4 to R5 now. And the router LSs generated by R3, see, flags, B bit is what? It means R3 is working as an
APR.
and this ABR's information is going within router LSA. Cool. Now you can move on R5 and you can see all routers are coming. Routes are coming from area 0, but as a inter area route. As inter area routes are coming, all routes are coming from different area, from area 0 into area 1 as a inter area prefixes, right? So all of them are present here as inter area IA, and you understand very well that what is the meaning by IA. Understood or not? So IA means inter area, means they are coming from different areas now. Now if you check its database table, because I said that routes will always come in the form of summary LSS, and summary LSS will be generated by ABR only. Understood or not? So these summary LSS have been generated by ABR only, and I said, actually I taught you before that, okay, summary LSS will be generated by ABR only. So right now 3 is working as an ABR, and we have seen it. Even you can run this command as well, show IQSP border router, that R3 333 is working as an ABR, and this is the cost to reach this ABR. Now try to understand the whole process going or performing behind OSPF. R3 is that router which is having or which is participating in area 0 as well as
area 1.
fine. So it means R3 will be having router LSAs of area 0 as well as
Area 1.
how many routers are there in area 0?
3 routers.
How many router LSAs will be present?
3.
How many routers are there in area 1?
2.
It means Balaji. So 3 router LSAs will be available in area 1 itself. And R3 will be having all 3 router LSAs of area 0 as well as of area
1.
Let me show you. This is the database of area 0. How many router LSAs are there?
3.
This is the database of area 1. How many router LSAs are there for area 1?
3.
Now, ABR is also responsible to break. I will not say to break router LSA. I will say, let's say that it is having the database of area 0. It will run SPF algorithm. It will install best route inside its routing table, and for those best routes only, it will create summary LSAs. Are you getting my point or not? So first of all, let's say that it is having the database of area 0. On that database, it will run SPF algorithm, will install best routes inside its own routing table, and for all those routes which are available inside its own routing table, it will be responsible to generate summary LSAs. Fine. So for the router LSAs of area 0, it will generate summary LSAs for area 1. See, because I mean the loopback of R1, the loopback of R2, the loopback of R3, they were participating in area 0. And the 12th network in between R1 and R2 and 23's network between R2 and R3, they were participating in area 0. And this R3 is receiving that information in form of router LSAs, but also it have broken them into summary LSAs. I mean, it have also generated summary LSAs. Now you must remember the path selection process of OSPF. Path selection procedure of OSPF. Like, first of all, intra-area, then inter-area. Intra-area will always be preferred over. Are you getting my point or not? Intra-area will always be preferred over inter-area. Then, so this time it is also possible that you are receiving same prefixes as intra-area as well as inter-area, but OSPF will always prefer, like here R3 is having, however, it would be like kind of laughing if I am saying this statement, if I am giving you this statement, but just try to understand that in the database of R3, it is having the loopback of R1 in form of router LSA, and also it is having some DLSS for it. However, that some DLSS is generated by itself. But again, it is preferring, like in the routing table of R3, you will get this one as intra-area. And this time you can see that this ABR, this R3 is not having any prefix as inter-area because it is connected with all area. However, it is having some DLSS too, but it will not install them inside its routing table because intra-area is always preferred over inter-area. So here you can see that on R3 we are having all prefixes coming as intra-area because it is participating in area 0 as well as it is also participating in area 1. If you are having any problem, please let me know. Fine. So this time summary LSAs have been generated by this ABR. Great. Let's move on R5 now. R5 is receiving this 111, the loopback of R1. But this loopback of R1 is coming as inter area, and inter area will always come in the form of summary LSA. Show IP OSPF database. So this 111 is coming in the form of summary, and the summary LSA is for area 1 only. Generated by 333. As I said, that summary LSA under link ID it will be having your network ID. Under advertising router it will be having the router ID of advertising router. So who is the advertising router this time? R3. That is why it is having the router ID of R3 under advertising router. But under link ID this is not the router ID of R1. Do not think that this is the router ID of R1. This is the loopback address of R1. Because I'm also using router ID as addresses as well. However, it could be beneficial for us to understand this OSPF to use different router IDs. Should I use that? Like 10, 20, 30, 40, should I use that? Router IDs of routers. Okay, forget about it. In next class we will see that. So advertising router is now this. So now you do one thing, open the summary LSA, so IP OSPF database summary for this prefix only. What is it saying? This is what network number, this is network ID, and this is what subnet mask, and this is what metric. But this metric is not from R5. This metric is given by, because this information is given by 333, and you do not have any information about this prefix except that okay, it can reach it via ABR. Now does R5 have this information that where is this 1111 exactly in this network?
Yes.
Hello, does it have this information? How?
ABR उस पार इतना ही पता.
अब कहीं भी हो सकता है ना, पता नहीं ABR के उस पार कितने राउटर्स हैं. So does it have a complete topological database now? That is why we says that in case of inter area, in case of multi-area OSPF, now your OSPF will become partial link state, not fully link state. Hello.
मैट्रिक से पता चल जाएगा.
वाओ ग्रेट. इसको पता है कौन सा राउटर कनेक्टेड है? R1 है, R2 है, कुछ पता है? पहले पता था ना? So this feature is taken from distance vector routing protocol now. Because we are relying only on that information which is given by the ABR. This is the metric. It's not it. Previously, in fully linked state routing protocol, in single area OSPF, routers were calculating their cost by themselves. But this time, for their metric, routers are depending on that information which is given by an ABR. So this feature is taken from distance vector routing protocol. Now you do not have complete information. Because we know that okay, this information is given by ABR. That's fine. I know very well that who is ABR. Show IP OSPF border. But after behind R3, how many routers are there? How are they connected? We don't know anything. And remember, network LSAs too cannot move from one area to another area. Let me show you that here on R5 show IP OSPF database, it has generated network LSA itself. This is generated by R5. But this is only for area. Remember, network LSA cannot move from one area to another area. Let's move on R1 now. Does it have any network LSA now here?
No.
So it does not have complete information. That's why we say that in case of multi-area OSPF, your OSPF will become partial linked state routing protocol. Have you understood it or not? For sure. Hello. So now on R1 also you can have some inter-area prefixes like the loopback of R4 as well as R5. So this time, what is the cost to reach the loopback of R5? 203. But if you open this LSA show IP OSPF database summary for 55555, so it is showing you that okay, what is the metric? But here it is showing you how much? 203. So how is it possible? See, this metric is given by R3 ABR. You have to add the cost to reach ABR as well. So this router, show IP OSPF border router. See what is equals to this ABR is 128 plus 75.
Yeah.
It will become now
20.
Sardeep, are you okay with it? Little bit. Fine. And now I will show you that, let's say, show IP interface brief. My loopback is up. Say show IP OSPF. How many times it have executed SPF algorithm?
4.
Base 1.
3 times.
Base 1. For area 0 it have executed 3 times. For area 1 it have executed 5 times. R4 show IP OSPF. For area, because it is running only area 1, so it have executed only on R5 show IP OSPF. It have executed only 2 times for area 1. Now on R5 show IP OSPF database, you are having some real SS for 1111, is not it? Now you do one thing, move again on R1, shut it down. So it will run SPF algorithm for area 0. Previously it executed only 4 times, but this time it will be 5 times, and it will remove it from its area 0, right? And then you move on R2. Do you have 1111 available here? No. Show IP OSPF. Previously it executed how many times? 3 times, but now it is 4 times. Then move on R3 also. Show IP route. Do you have that 1111 available here? No. Show IP OSPF. Previously for area 0 it executed how many times? 3 times, but this time 4 times. But for area 1 previously it was having only 5 times, and now also it is having only 5 times. There is no effect on area 1. Even you can move on R4 as well. Previously 2 times, and now also it must be 2 times. Even you can move on R5 as well. Previously it was 2 times, and now also it must be 2 times. And now if you check its database table, show IP OSPF database, you will not get that some DLS actually, because this time ABR will not generate that some DLSA. Hello? Because R3 ABR have not installed that 11111 inside its own routing table. So if your ABR does not have any route in its routing table, then it will never generate some RLSA for that specific prefix. Understood or not? Great. Fine. Let's go for next topic. So this is that how multi-area OSPF is helpful for us, just to reduce CPU utilization. But the problem is that now it is not fully linked state. It is also, it have become now as partial linked state routing protocol. Fine. The default AD value for OSPF is what? 110. You can also change it, right? Fine. Now let's talk about area types. Here by default it is point to point. Let me show you. Show IP OSPF interface serial 1 by 0. On serial interfaces by default your network type is what?
Point to point.
It means on R2 also it is point to point. If you want to configure IP OSPF network type is what? Broadcast here. You can configure it. Even neighborship will come up, don't worry. Neighborship will come up because timers are same, and for OSPF it is not written anywhere that okay network type must match. Only timers must match, and in case of point to point and broadcast timers will match. Timers are same. It will simply wait to configure itself as a DR because network type is broadcast. Neighbor is not participating in DR BDR election because network type is what? Point to point at the end of R2. That is why this time R2 is not participating in DR and BDR election. That is why R1 will become now DR, and it will form neighborship with R2. Don't worry about that. Access start will move into exchange state, and finally it will move into full state. So it has configured itself as a DR, and once after configuring DR, neighborship have came up into full state. Now show IP route. Does it have any route available here? But neighborship will remain there. So it can happen in case if in a single segment if you have configured your network type as point to point on one end and broadcast on another end. So make sure that in this case your network type must match on both ends. So move on R2 now. On it says 1/0 also I'm going to configure IPv4 network type is what? Broadcast. This time they will perform DR and BDR election so that they will form neighborship because R1 was already elected as DR. And now R2 have immediately elected as a BDR. And now it has formed a neighborship with R2, show IP route, all routes must be there. And now inside the database of area 0 itself you must have that network LSA because now DR and BDR election is there.
Yeah.
So remember, it is not true to say that if your interface is serial interface, DR BDR election will not be there. It will be depending on network type of OSPF, not interface type. Have you understood it now? Like in this case, they are electing DR and BDR in between R4 and R5. R4 and R5, right? Now you do one thing because we know very well that we are having only two routers on this Ethernet segment. So it is always better idea to configure its network type as point to point. Otherwise, convergence time will be higher. Are you getting my point or not? So it is always recommended, it is always good to configure your network type as point to point even over Ethernet links too, if you are having only two routers available in that Ethernet segment. Hello?
Yes.
Are you okay with it?
Yes.
So remember that you must be having only two routers in the Ethernet segment. If you are having more than two routers in a single Ethernet segment, then you must not configure its network type as point to point. In a multi-access network, if you are having only two routers, configure point to point. And in a multi-access network, if you are having more than two routers, then never configure network type as point to point. Otherwise, there can be a big problem. Even we can prove it. Like this time, first of all, let me do one thing. By default, its network type is broadcast onto Ethernet. I'm going to configure their priority as 0 so that no one will be eligible to become DR. So we will see that their neighborship will be stuck in two-way state now. Because in between two DR others, because now if you configure their priority as 0, it means they will never be eligible to participate in DR and BDR election. So that both ends will become DR other now. See, if Ethernet port with the network type broadcast is not either DR or BDR, it means it will be DR other. And in between DR others, in between two DR others, neighborship will never be formed. Neighborship will be stuck in two-way state. You do one thing, move on R4. IPOSPF priority 0. On R5 also, interface FA0/0 IPOSPF priority 0. Show IPOSPF neighbor. Just wait for a moment. See, they have moved actually into two-way state now immediately. But if you configure priority as only on one end, then they can form neighborship. Their adjacency can move into full state then. Hello.
Yeah.
Understood or not?
Yes. Sir, can you show static neighborship?
What?
Static neighborship.
I will do everything, don't worry. But I can't perform everything together. I will not skip any single topic.
Actually, what will be the command?
Don't worry. It will be covered now in next class. Fine. So the others neighborship has stuck in two-way state. You do one thing now. Go to R5 FA0/0 and configure IPOSPF. Network type is what? Point to point. In same manner, move on R4. This time there will not be any problem, right? Because in case if their priority, because in case of point to point, your default priority is also 0. So there will not be any problem anymore, even after configuring priority as 0. Show IPOSPF neighbor. See, R4 is having neighborship with R5. If you move on R5, R5 is also having neighborship with R4. And there is no transit network now in the router LSA of R5 and also in the router LSA of R4. So IPOSPF database router 5.5.5. There is no transit. Now it will be stub network. See, because this time they do not have DR and BDR election onto this subnet. So I hope that now you have understood the difference in between stub and transit as well. Wherever you will find transit, it means it is having some neighbors onto this network, and it is also having DR and BDR over there. If it is a stub, it means it's a stub network and a network. Might be it is having neighbor, but only point-to-point neighbor. But for point-to-point neighbor, it will be having a different entry. Have you understood it or not?
Yes, sir.
So wherever you will be having transit network inside router LSA, it means it is having DR, BDR over there. Even like you can move on R2 and then you can open router LSA generated by 11111. This time you must have transit network, you see, because this time you configure their network type as broadcast in between R1 and R2. Fine. Rest of the things we'll discuss in next class.